Hi. So in this problem, we are going to talk about a probability question. Let's understand the question first. There is an information station that uses four different codes, A, B, C, D, but each week will use only a single code. And how do we select the codes? The code used in a particular week is randomly selected with equal chance from the three codes that were not used in the previous week. So basically, what does that mean? So if I start with code A in the first week, right? The next week, I have to select the code to use from B, C, and D randomly. So basically, next week could be either B or C or D with equal probability of 1 by 3, right? And it could be, let's say it was C. Then the next week after that, it can be A, B, or D with equal probability. It could be A, it could be D. So it's a pretty simple method. You are using a code in the next week, which is the one that was not used in the previous week, and out of the three remaining, you can use any one with equal probability, right? The question is saying, suppose that the code used in the first week was A, find the probability that A is also used in the seventh week, right? So this question can be solved in multiple ways. The standard method for this would be conditional probability, where they have said that the code used in the first week was A, and they have to find the code probability that A is used in the seventh week. But we'll solve it in a slightly different method. We'll use a recurrence relation for this. So let's see how we set up the problem. Let's define the term PK. PK is the probability that A was used in the kth week. A was used in kth week. So obviously, if PK is defined like this, then 1 minus P of K is basically probability that A was not used in the kth week, right? A was not used in kth week. The probability for that would be 1 minus P of K, correct? Now, let's think about how to make P of K plus 1. What is the probability that A was used? Probability that A is used in the K plus 1th week, right? If we try to think of this, we immediately realize that if K has to be used in the K plus 1, if A has to be used in the K plus 1th week, then A cannot be used in the Kth week, right? So basically, it implies that A was not used in the Kth week. So we can say 1 minus Pk has to happen in the Kth week, A is not used. And after that, the probability that A was used in the next week would be simply 1 by 3 because it was selected with an equal chance, right? I hope you understand why Pk plus 1 has to be 1 minus Pk multiplied by 1 by 3, right? Because if we understand this, then we can set up the recurrence, right? So we are getting this equation Pk plus 1 is equal to 1 minus Pk into 1 by 3. And now I want to solve this recurrence relation which connects Pk plus 1 to Pk. So what I will say is if I do minus 1 by 3 here, I will get Pk minus 1 here. And I want to create a similar term on this side, right? So I can say, I can just put Pk plus 1 here and just expand it a little bit. So minus 1 by 3, I will break apart the 1 and use Pk minus 1 by 4 minus 3 by 4. You'll realize why I'm doing that, because when you multiply minus 1 by 3 with minus 3 by 4, it will become plus 1 by 4. And that can go on the other side. So we can say this is minus 1 by 3, Pk minus 1 by 4, and plus 1 by 4. And this 1 by 4 can go on the other side, and we get Pk plus 1 minus 1 by 4 is equal to minus 1 by 3, Pk minus 1 by 4. Now, what is the idea here? We're getting similar terms here, and there is a factor or there is a common ratio of minus 1 by 3 here, right? So if you say P1 was 1, this is an initial condition. Why is this true? Because the question itself had said that the first week the code used was 1 A. So the probability P1 will have to be 1, right? So if P1 is 1, then you will get P2 minus 1 by 4 is equal to minus 1 by 3, 1 minus 1 by 4. And therefore, you get minus 1 by 3 into 3 by 4 this is minus 1 by 4, and you get P2 minus 1 by 4. So you're getting P2 is equal to 0, which makes sense because if P1 was 1, P2 has to be 0 because A cannot be used in the second week now, right? So that suggests that our recurrence is correct, right? Now think about this. This equation implies that we have a sequence Pk minus 1 by 4, and this sequence is a GP with common ratio minus 1 by 3. Common ratio is minus 1 by 3, right? This is a standard GP. This is a quantity, and this is the next quantity in the sequence, and this is the previous quantity, and you get the next quantity by multiplying the previous quantity with minus 1 by 3, right? So that is a GP. So if we have a GP setup like this, then we can easily write the nth term, right? So let's try to write the nth term for this GP here. So I will just create some space here, and I can say that Pk minus 1 by 4, the nth term of a GPAN is first term multiplied by R common ratio to the power n minus 1, right? We are using that formula. We'll say Pk minus 1 by 4 should be equal to first term. First term would be P1 minus 1 by 4 multiplied by common ratio minus 1 by 3 and raised to the power k minus 1, right? Because this is the kth term and I want the kth term's expression. So I'll put k minus 1 power here, right? Now P1 is 1, we already know. So this is becoming 3 by 4. And this is minus 1 by 3 to the power k minus 1. And this is Pk minus 1 by 4. So finally, we get the expression for Pk, which is equal to 1 by 4 plus 3 by 4 into minus 1 by 3 to the power k minus 1, right? This is my expression for Pk, which says the probability that A was used in the kth week, right? Now the question is simply find P7, right? Probability that A was used in the 7th week. We have already used the condition that A is used in the first week by saying that P1 is 1, right? So P7 we have to find. Let's find that. We'll just put K is equal to 7 in this. So we end up getting something like P7 is equal to 1 by 4 plus 3 by 4 into minus 1 by 3 to the power 6. 7 minus 1, 6. So this becomes 1 by 4 plus 3 by 4 into 1 by 3 power 6. So that is 3 power 5 here. So you get 1 by 4 plus 1 by 4 into 243. So it will be 243 plus 1, 244 by 4 into 243. And 4 will cancel here and it will become 61. So P7 is coming out to be 61 by 243. That is the probability that A was the code used in the 7th week. So I hope you understand what is happening here. We could have tried to solve the question by conditional probability, but I think that will be a little longer than the solution that we have presented here, right? Here we are trying to set up a recurrence where we are saying the next term in the series can depend on the previous term, and we are solving the recurrence. And the technique that I've used to solve the recurrence is a standard technique. We want to create a situation where you have similar terms on both sides of the recurrence equation, and we identified that this was a GP. And after that, solving it is trivial because we know GP formulas, right? So hopefully you have learned something from this question. If you like the video, please consider subscribing to the channel. I'll see you in the next video.